Thank you for joining us for Rumsey's ongoing webinar series being hosted by Rumsey Specialists. Today we're going to talk about the Connected Components Workbench and its interaction with PowerFlex drives. My name is Sean Huber. I'm one of the automation group's managers here at Rumsey. And I guess I just want to cover a couple of housekeeping items before we turn this over. First and foremost, you're not necessarily muted, especially coming into this WebEx. So if you could just mute yourself, but feel free to unmute yourself and or chat in questions if they would arise over the course of the presentation. We are recording this presentation, so you'll be able to rewatch it or forward to others as appropriate. And we will be posting this on Rumsey's YouTube channel, so you have a place to reference it and come back to it later. Lastly, we will be following a follow-up email to everybody in attendance. We'll have any of the supporting documentation Jared talks about, as well as a copy of the presentation and a direct link to the recording itself. So with that, I'd like to introduce Jared Roberts. Jared is one of the 3 drive specialists here at Rumsey. He will, at the end of his presentation, post his contact information. But if you do have any topics on anything drive or power related, feel free to always go to rumsey.com and you'll see all of our contact information there. So feel free to reach out to us at any point. And with that, Jared, we'll turn it over to you.
Okay, thank you, Sean. Good morning, everyone, and thank you for tuning in. My name is Jared Roberts. I am one of the drive specialists at Rumsey Electric. Been with Rumsey for about 7 years, handling drives. Before that, I was supporting a different manufacturer's drive product. Today we're going to be covering using Connected Components Workbench software with PowerFlex drives. I'd like to start covering Connected Components Workbench software in general. For those who aren't really familiar with the software, we're going to spend just a minute or two covering the general software itself, and then we're going into using Connected Components Workbench software specifically with the drive products and the features pertaining to PowerFlex drives. Lastly, we're going to actually launch the software and use the PowerFlex 525 startup wizard to configure a drive. One behind here. So what is Connected Components? It is a microcontroller-based platform for smaller standalone machines. There are a number of different products that can be configured using Connected Components Workbench software. The list here shown at the bottom, there are the Micro 800 controllers. What we're here to discuss today, the PowerFlex drive, Panel View 800 graphic terminals, Guardmaster safety relays, and a bunch of others as you see listed below. So Connected Components Workbench software is a single software that supports configuration of devices such as the PowerFlex drives, programming. So we have a program editor in here for the micro logics and even device logics, which we're going to get into later today, and a visualization editor, which allows us to develop screens for the panel views. So moving on to using Connected Components Workbench software with PowerFlex drives. There are multiple options for programming and interfacing with PowerFlex drives. I think most are familiar with the traditional way of programming a drive via the keypad or the drive HIM. So basically, you'd be standing in front of the drive, viewing and editing a single parameter at a time. Connected Components Workbench software helps us to basically get the drives up and running using an intuitive interface and configuration wizards. So we can configure program, monitor, and control from our computer. We have access to application and trending wizards. You can save or back up configuration files to your computer. And it's designed to be used for standalone machines. Lastly, Studio 5000 can be used for programming drives as well, drives that are integrated and being used along with a Logix 5000 controller. And this gives us additional features, which would be Premier integration using add-on profiles to configure the drive, and also automatic device configuration. So Rockwell provides the same user experience involving device configuration between Connected Components Workbench and Studio 5000. So what we see here in the slide, the bottom left, is a configuration screen for a drive in CCW. And on the right-hand side is an add-on profile that we would see in Studio 5000. And you can see they're almost identical. So if someone is familiar with using Studio, for instance, and they needed to do an application with a standalone drive, it might not be with the Logix controller, they should be comfortable configuring a drive in there. And the same goes if you were already programming or configuring drives in CCW and needed to do something in Studio, you'd look and have familiarity there. So Connected Components Workbench software supports configuration for all current active PowerFlex drives, including the new PowerFlex 755T and medium voltage drives. So in the next few slides, we're going to cover some of the features and navigation of the software. So the start page is your launching point for starting a new project, opening existing projects from file, and also browsing or looking for available devices that we can connect with and go online. When we first open up the software, you're going to see basically a start page. On the right-hand side, there is a device toolbox. There we can actually look for or discover devices that are available to connect by expanding the project connections and look for connection browser or look for available devices that way. And also below that, there is a catalog, which if we expand gives us a list of available devices that we can bring into our project to work offline. If we select a device, it'll be brought over into the project organizer, and we can start working on our project. Also have the ability to copy and paste devices into the project. This can save us time if we have multiples of the same drive or they have a similar control. We can right-click on the device in the project organizer, select copy, and then paste as many instances as we need into the project. And we can see here, if we highlight or select a device in the project organizer, information is displayed over to the right of it in the main work area. So this slide just gives a little detail here regarding the device window. At the top of the page, and it actually displays the name of the device that we have selected here in the project organizer. So what actual device is being looked at here. Below that, we have information relating to the concerning the device itself in the main device page. And on the left, we have the navigation tree, which displays available functions for the device here. Okay, so the navigation tree, like I mentioned, we have a bunch of different functions we can select. If we were to click on parameters, basically all of the parameters for the entire drive are shown here in numerical order. There's quite a few parameters available, so we also have the ability to actually filter down and refine that by searching here. So we can filter by port as shown. We can also, with certain devices, filter by group or parameter group. And we can also actually select and show non-defaults. So this is a nice feature if we want to quickly look at any parameters that were changed in the drive. To the right of that, we have the ability to actually filter a value by putting in a keyword or a parameter name to narrow down the parameter instead of hunting through the list. And just to the right, we have the ability to reset the parameters to default. For whatever reason, we determine we want to start from a clean slate, we can reset defaults. And we also have the ability to select which specific port we want to reset as well.
Jared, I just want to make sure to point out to everybody, you had mentioned it with the non-defaults, but there was a time way back with drives when you didn't know necessarily what somebody went in and changed and you were having some issues. You would basically reset a drive to defaults and kind of start over just because it was so hard to find them. So from a pure troubleshooting standpoint, the ability to go into any of the PowerFlex series and see what has been set versus the default value is extremely from a troubleshooting standpoint.
Thank you, Sean. So specific to the 520 series drives, they also have an app view and custom view features in the parameters. App view actually puts groups of commonly configured parameters together based on their application. For instance, there are selections for conveyor, mixer, pump, fan, and so on. The custom view shown on the right allows you to create your own list of parameters you would like to have grouped together. So if there's a bunch of parameters you commonly use all the time and you like to see them all in one spot and be able to view them at once or not have to hunt around between different groups and so on, you can put them all in a custom group. The startup wizards lead you through configuration of the necessary parameters, basically to get your drive up running as quickly as possible. There's a startup wizard available for each drive family in CCW. And here, like I said, it's going to take you step by step through the process to enter motor control data, speed reference, configuring I/O, etc. So it's a very useful tool. The wizards are available for each drive, and depending on the device, as you can see here, when we select in the actual navigation tree on wizards, there are different wizards available for each drive type. So the 520 series might have and does have different available startup wizard and wizard options from, say, a PowerFlex 750 series. The PowerFlex 750 series has embedded device logic capability. This provides the ability to function as a standalone system or operate together with a controller. The device logics can be configured using the logic editor in CCW or Studio 5000, and it's programmed using function block or ladder logic diagram, or ladder logic programming rather. Some examples of device logic functionality would be controlling logic command bits, or controlling a speed reference, monitoring logic status or speed feedback, and reading and writing different parameters. Moving on to some troubleshooting features. At the bottom of the connected component screen here, located on the bottom right side of the commit bar, there is a help button, and when we select that, it launches multiple different help resources. One is software related help. Another is actually product help. It's specific to the device we have selected at the time, and it provides quick access to parameter information related specifically to that particular device. There's also access to the product manual. So if we need the tech data manual or the user manual for that specific drive or device we're working with, we can get access it right there. It launches the PDF and we can reference it as necessary. And then at the bottom is the tech support wizard, which we will touch base on a little bit in more detail later here. We also have the compare function, so we can look for differences between programs or devices. We can compare the drive to the defaults, what we have on file, or another device. And you can see here the overview function, the top left, there's the compare button, and we can select how we would like to use the function. As Sean mentioned earlier, and we touched on briefly, was in the parameters, we have the ability to show non-defaults, and as Sean mentioned, it could be really useful as a troubleshooting tool. And simply by going into the parameters, either in all ports or in a specific port or group, we can show all the change parameters for that. Moving on, there is a function for faults and alarms, which will show the current status of the drive and also display the history of any faults or alarms that occurred. We also have the ability to clear faults for the actual fault history in the faults and alarms. Next is the diagnostic items, which displays a bunch of parameters that are related to the status and really give you an idea of what's going on with the drive. They're all grouped together in what we call here the diagnostic items. So useful for really determining the current status and seeing what's going on with your drive. Allows us to access multiple parameters at one time. As you can see here, we're looking at our reference and also our logic status. And we'll confirm that the proper operation or that our drive is configured and functioning properly. There are several predictive maintenance parameters available in the PowerFlex 750 series drives. So these parameters can track runtime or cycles for internal components on the drive. They also have the ability to track the runtime of your motor or machine, so we can get notifications if we require some type of maintenance or bearing and lubrication, for instance. So the predictive maintenance parameters for the 750 series drives can be configured using the keypad, Studio 5000, or Connected Components Workbench. And the predictive maintenance parameters are located in a group called Predictive Maintenance in the protection file on the 750 series. As you can see in the screenshot, we're in the predictive maintenance group. All of the available parameters are displayed there right in front of you. You can easily see all your options and what to configure at one time. It probably lends itself a little bit better than hunting through the keypad, in my experience at least. There's also a trending capability in connected components. So if we need to actually capture or analyze data um, based on how the drive is operating, we can start a trend and hopefully be able to gain a better insight into what is actually going on with our process. So over in the project organizer, next to the devices tab, we have a trends tab. If we select that, we can click the add trend icon, and a trend properties window will populate in the main project area. It'll give us basically settings that we can set for our application to create the trend. And this slide basically gives us an example of what we can expect to see in the trend tool. We have the ability to choose different types of triggers. So depending on what we need for the application, we can have and choose what would start capturing our information. And then the trend tool actually has the ability to gather pre-sample information. So we can gather up and know how the drive is acting before the actual condition we have set for the trigger is occurring. And then the trigger itself is displayed with a vertical red line here to let us know when the event occurs. Once we capture all the necessary information, we have the ability then to export it as a file or print it for our reference. As mentioned earlier, the tech support wizard is available. Say we're having issues solving a problem related to our drive. Many times Rockwell tech support can help with this. In order for them to gain insight into and offer any suggestions, typically they need a lot of information about your application, the drive itself, how it's programmed, etc. So the drive tech support wizard actually goes and gathers all of the standard data that's required or requested by tech support and saves it into a file. And what that does is minimizes the time going back and forth between Rockwell and yourself, trying to get all the information they need to help you in the troubleshooting. So this slide shows the different ways to connect with the drive and your computer using connected components. So the first option is the 1203 USB. It's a serial to USB converter that can be used to connect to all PowerFlex drives. So the 1203 USB connects between a USB port of your computer and either the DSI or DPI port of the drive, depending on what product family or drive family. So the 1203 USB comes with all the necessary cables and drivers necessary, and it also it would connect directly from your computer to the drive itself. Okay, so it's really a local connection. It's also possible to connect over Ethernet if the drive has Ethernet IP communication. An example of this would be a PowerFlex 525 or a PowerFlex 750 series drive with embedded Ethernet ports, or a drive with a network option module like a 20COM-E, for instance. In this case, there's no special cable required. We can connect using a standard Ethernet patch cord, and this gives us the ability that we can connect directly to a drive on the Ethernet port or a drive remotely over a network. So Connected Components Workbench uses drive database files when working offline. Typically when we have the latest revision of software, you will have all the latest database files. But from time to time, there are firmware changes or new product releases in between development or releases of software revisions. And that might require us to go out and get database files. So They're available, the database files and the firmware files are available at Rockwell's Product Compatibility and Download Center. There's actually a link to the Download Center. If we use the Help dropdown in CCW, it'll take us right to the area where we can actually get that information, whether it be firmware or database files. Another option would be if we don't have the actual database files for that particular product, we can connect directly to it online, and the database files will be created automatically. This, depending on the drive product, and if, for instance, we're using, say, a serial connection, can take a fair amount of time, depending on which device, like I said, you're going to connect to. So sometimes it might be advantageous to actually download the files with an internet connection, from the download center prior to going out into the field. If that was the case. Okay, so at this point, I'd like to launch the Connected Components Workbench software, and we'll go through using the 520 series startup wizard. So as mentioned earlier, we have the start page upon the opening CCW here, and we have different options. If we want to connect to a drive here, we can use the Discover button, or again, we can expand on the right-hand side and use Browse Connections under the Discover expansion or tab here in the toolbox. We click Browse Connections. Today we're going to be using the 1203 USB serial connection. I've connected to the drive here locally to me. So in that case, I'm going to go and expand the Data Highway Plus and look for a DSI connection since it's a component class drive. Click on OK, and we can see we're connecting to a device. So once we've established connection, we can see here the overview function tab of the navigation tree is highlighted, and we have a PowerFlex 525. It shows the actual rating and revision number. We can select and say add it to a project, and we will begin uploading the information from the drive. You can see once it finished the upload, now on the left-hand side in the project organizer, the 520 series drive is displayed, and it also has a green box around it and the green bar across the top of the screen, meaning we're actually connected with the drive itself. So through the navigation tree, we're going to go down and select wizards, and with that, the available wizards are displayed. And at the very top, there is the PowerFlex 525 startup wizard. We're going to go ahead and select Start. Wait for that to upload. I'm just going to drag this over so everybody can see it. So what we have here now is the PowerFlex Start Up Wizard, and the first thing that comes up is a welcome screen. It explains that if we hover with our cursor over the parameter or option, it should give us additional information displayed there. And basically, once we finish entering the required information in each page, we can just hit the next, and it's going to take us to the next required step. It's basically going to lead us through all the options or most things that we're going to need to configure on a typical startup. So at the very start, it gives us the option to reset the drive to parameters, reset the parameters on the drive rather. And here we have a couple different options. We can retain if we had custom group parameters already made. We can reset everything, including the custom parameters, and then we can do just power parameters. Today we're going to select reset all the factory faults, and then say yes. And the reset occurred almost instantly, as my drive indicated here locally. But shortly, we should get verification on the screen as well that parameters were reset. So once that is finished, we can select the next step. And in our case today, I'm going to stick with English. So moving on, it prompts us to select our desired method for motor control. Here, depending on the drop-down selection here, or what selections are made, we have a different options available, or become available rather. So if we make different options, we can input different information depending on what we select. We're going to stick with sensorless vector control, and then move on. In this screen here, we would enter, which is critical for any application, the motor nameplate or motor data. So in this case, I'm going to just set up my information for my specific motor here on my demo. I'm going to enter my overload current and my full load amps, and then change my RPM and my motor rated power. Once we've entered that information, we can move on to the next step. In this case, if we were going to be using any type of feedback, like an encoder, we could enter that here. And then it carries us to the stop and brake type configuration. So if we were going to be using a dynamic braking resistor, we could enter that. And below that, we have the option to select the actual stop mode for the drive. So you can see here, there's different stop functions, and there's also a CF behind some of these options. So the CF actually stands for clear fault. We weren't aware of that. I'm going to stick with ramp and clear faults as a stop function here, and go to the next step. Okay, this portion of the startup wizard actually does a direction test for us. Okay, and if you recall earlier, we did a reset of parameters. Once we perform that function, the drive actually faults at a F48, letting us know the parameters were reset. So we're currently in the faulted status. And if you remember here, a step earlier, we had selected the stop as a clear fault. So we should be able to reset the fault here right from the stop button, which we were able to do. In this case now, we can actually, if it was safe to do so in the field, bump the motor and verify direction if we wanted. So here I could set a jog speed and use the jog function by just holding it down, and momentarily we can see on the display on the right that we're actually running the drive at the desired frequency in the jog function. And I'm not sure if you can hear in the background my drive fan, the heatsink fan is actually turned on because we were in fact running the drive. We can also use the run function if that was required, or that was your preference. You can actually run the motor in a direction and verify rotation up here. And again, if we hit the start button, it says that our speed reference is not currently set for the COM port. So it would do that for us if we would like. So we're going to say yes. And here now we can see the drive is accelerating to the reference I specified. And we can stop the drive. If we verified that rotation was okay and we're all right with that, we can select yes and proceed to the next step. So this step in the wizard allows us to do or perform a Autotune feature. We have two choices here for the 520 series. We have a static or rotate tune. The static tune would be for any instance where we could not uncouple the actual motor from the load. If we had, or we were uncoupled, then it would be okay to do a rotate tune if it's all right for your application. Either way, we'd only really need to do one tune. If we do the rotate tune, it actually performs the static first and then the rotate. In this case, I'm going to select rotate tune, and the drive is going to start the tuning process. So within a few moments, you might be able to hear that the drive is actually running the tune here in the background. Now we're into the rotate tune portion of the test. We can actually see the drive is ramping up through different speed range. Okay, so now that the test is completed, we can proceed. So in the ramp rates and speed limits section, we have the ability to change our maximum and minimum frequency. And we can also set our XL and decel time. So here, if we wanted to, we can change these rates to the desired value and move on if you're satisfied. In this tab, we have and set up the speed reference. The speed reference is required to tell the drive what source or what to follow as far as a speed command goes. So remember back in our direction test, the software helped us to change it to the serial connection so we could make an adjustment there over to software. We're going to change that now to the drive potentiometer, or the pot that's on the face or the keypad of the 520 series drive for local control here. And as you can see listed at the top, there are different options, so we can have multiple speed references depending on the application requirements. Today, we're just going to kind of focus on the drive pot. The 520 series has an embedded Ethernet port. If we wanted to set an IP address for the drive, we can enable parameters, and then it would give us the option to actually set the IP address, subnet mask, or gateway accordingly for your application. Moving on to the digital inputs, you can see here we have another opportunity to change or set our stop mode. At the very top, we want to set our start source. This is going to tell us exactly what we're going to use to command the drive for start, stop direction, for instance. So right now, it's the main start source is configured for the serial DSI connection. We're going to change that to the digital terminal blocks, or the terminals on the drive. Okay. Here we can use that one, but not sure it's necessary. Today we're just going to focus on the terminals, and we're going to actually set up a digital input to change the start source to keypad reference, just to give you an example of changing a reference. On the first input of the drive, it's designated, it's not configurable, it's always a stop command. The second digital input, we're going to configure as 3-wire start, and it's just the way my demo here is configured today. And for digital input 2, or terminal block 3, rather, we're going to use 3-wire direction. And then I have a selector switch wired to the digital terminal block 5 that we're going to use to actually change the start source to the second start source that I mentioned, as we configured for keypad. The remaining inputs we're going to change to not used. Okay, so I have changed to 3-wire start and 3-wire direction. I have a start source is digital in terminal block. My second start source is going to be keypad, And one other thing I'd like to point out here, if I actually change the position of one of my logic inputs on the drive demo, we see here an indication with a green indicator on the startup wizard saying that the actual bit went high on that input. So that can help us if we're programming the drive and we're not sure. We can get confirmation on where the wiring is actually landed on the drive, and that we're in fact getting the inputs we need or we expect to see from the field. All right, so once we're satisfied with our terminal or digital input selections, we can advance to the next step. And here it gives us the ability to program the relay outputs that are on the drive. So you could choose your functions here or what you would like to use the relay for. The same goes for the opto outs that are on the drive as well. And then if we needed to use an analog output to provide any type of feedback, we can select that here as necessary. Now that we've gone through all of the steps of the wizard, it prompts us with applied changes. So basically at the top here, it gives us a list of changes that were already made throughout the startup wizard, okay? And then below that, it's basically saying, here's a list of the parameters that we changed in the wizard, and that if we click finish, they're going to be made when we make the selection here. So we're going to go ahead and say, yeah, we're going to make these changes. Once we select finish, yeah, I'm going to go up to my diagnostic items and display the diagnostics area here of the drive. We can see right here we have the current speed reference on the drive. We also have the logic status, and we can see the current state. The drive is enabled, and it's not currently running. So if I hit the start switch, we should see the drive goes in running and accelerated, and once it accelerated up to reference, we even get the at reference indication. We can see if I change the speed reference, the drive responds accordingly. Here, if I select direction, we can see the drive decelerates and begins accelerating in the opposite direction. And once again, once it gets to reference, hit the stop button, the drive, you can see that it actually is stopped. And if I was to change the actual reference, I can operate it from the keypad as well. So I'm doing that. So pretty straightforward operation. And again, the startup wizard took us through all the steps necessary to get our drive up and running here today. So once we are happy with our configuration, we also have the ability to save it, right? So if I select the drive over in the project organizer, I can actually name the specific device. So in this case, I'm just going to call it conveyor 1. And if I want, I can actually save the project. We can call this whatever we like, and save the project for later reference. Okay. That's really all that's to it using the startup wizard. I'd like to go over a couple other things in here. We talked about navigating through parameters and such, and the 520 series doesn't have nearly as many as what for instance, a PowerFlex 5 or 750 series would have, with the multiple ports and the flexibility with the rack style architecture that we can add and subtract the option modules as desired. So if I go into the parameter selection, and on this 750 series drive, I can see all my port options that I have the ability to narrow down and select the parameters specific to the port. Okay, so again, I just selected a 24 volt I/O module, and here we can go into and set the relays or whatever necessary parameters for that is, or look specifically at the drive parameters itself. Also wanted to note that here we're looking at a drive that has 24 volt and 110 volt I/O modules installed. So we can mix and match the control voltage if necessary. And we also have the ability to add, COM modules or any other type of option module in there as well. All right. And we touched on during the presentation device logics. So here you can also navigate to our device logics parameters if you were using that functionality. In the navigation tree, there is a device logics function in which we can launch the editor, just to give you an idea what some device logics would look like if we were using that functionality in the drive. Here is the device logic editor showing some function blocks. And if you're familiar with any other type of program editing tool, this is what you would be used to seeing. Then if we select any variables, we can go ahead and see them in the drop down here, available selections. So just to give you an idea, the device logic editor. Okay. For those of you, and we might be able to get some questions on this later, but for anyone that is familiar with or has any files that are saved for older configurations using Drive Executive software, so if we have any drive configurations or backed up files with Drive Executive, we can also bring those older files into Connected Components Workbench, right? So we can actually go in and import a device file, and it could be, like I mentioned, an old Drive Executive file. So if we look here, this is actually an old DNO file from Drive Executive. So again, if we just select it and say open, it brings it right into the project for us here. And just like the other CCW, we have access to all the parameters and information for that drive. So that's really all I wanted to cover for the software. So let us get back into how do we go about getting the actual software. So the standard edition of Connected Components Workbench, and that's what we were using here today for this presentation, is available on the Rockwell website for free download. We can go navigate to the Rockwell software and find the Connected Component Workbench, or follow the link here and download it for yourself and get that to get up and running, programming your drive. I also wanted to make mention or list some available resources and information at the very top. Since we mentioned it today, the Device Logics user manual and also application-specific publication. Put links to that information up here at the top for your reference as you're interested in Device Logics or learning more about that. Below that, we have some product-related information, the 750 series installation instructions and 520 series user manuals. They're always handy to have access to. And below that, the information we recommend having or referencing for anyone that's using variable frequency drives. The wiring and grounding guideline recommendation is something to really take a look at anytime we're going to be doing a new or existing drive application, to reference that, to make sure we're taking all the proper steps to install the drives correctly. So I wanted to take a minute to bring some attention to other VFD related webinars upcoming. We have a webinar regeneration and braking considerations. So if you have a minute today, after this webinar, get yourself registered for that if you're interested. And then also we had some the webinars we ran prior to this that they were actually recorded. So if you go to the Rumsey website, you have the ability to watch any of those webinar presentations on demand. So again, if there's any interest there, go ahead and like I said, go to the Rumsey website. They should be available for you. Okay. Do we have any questions?
Yeah, thanks, Jared. Yeah, with that, there's a possibility I may have muted a couple of people, so just make sure to unmute yourself and feel free to ask a question or go ahead and chat any questions in that you may have. We'll just give it a minute.
Yeah, I have a minor question. Is there any way to use this application to simulate a drive that's not out there so you can navigate to parameters? If I'm setting up something, let's say a Siemens operation that's going to communicate out to this thing, or out to a drive that doesn't exist, can I use this application to drill into a parameter as a simulation?
So yeah, so if I understand you correctly, you would want to maybe just for an example, send a speed reference or something like that from a controller to the software to see if you could.
To test the mapping, to make sure it's not necessarily the drive is configured properly, but that the software to map out to it is configured properly.
Yeah, I think that might be difficult just because you don't have any physical hardware to land your signal to, right? So yeah, I would think typically you would need a device to land, whether it be comms or hardwired speed reference, for example, to a drive, and then you would monitor that.
So the software itself allows you to configure a drive being offline, but it doesn't allow you to emulate a drive.
That's all.
Yeah, to see what the reaction would be.
Yeah, the emulation side of it was what I was specifically asking for.
Not as of yet, but there's been an awful lot of development into CCW, as you can probably see with all the devices that it connects to within Rockwell's realm. But as of right now, no, nothing with the emulation side.
The other question is, I saw as far as generating trends, is there a way to have an OPC connection communicate out to this?
I'm not aware of. I'd have to actually get back to you. I'm not sure if anyone else could fill in on that and on the call.
My initial guess would be no, that it's sort of self-contained, but that would be one that we would have to maybe just double check on before we give it definitive. I know we can trend and get stuff to Excel, but it's sort of still on its own. It wouldn't be like live sending that information out. Now, that being said, if you have the ability to get this stuff into like a logic controller, you can always take that data from the drive into the logic controller and then pull the information out via OPC.
Yeah, yeah.
But yeah, I'm not sure with the help of the software. I think it's sort of self-encapsulated. Well, if there's no other open questions, we'll wrap up. But Jared has his contact information on the screen, and as I had said when we opened up this presentation, all of the Rumsey specialists across the board All of our information is up on rumsey.com, so feel free to pull our information from there and be in touch with us. So with that, thanks for tuning in today. And if you have any questions, feel free to reach out. Don't forget that we'll continue these tech talks and webinar series into the foreseeable future every Tuesday on a variety of different topics. So feel free to go check out our website and sign up for them as appropriate. With that, thank you, everyone.
Thank you.